So these are the questions that we went over in the office hours for period 1 and 0 today. This first question is from the trig packet, number 2. So John is driving across the desert. He stops and measures the angle of elevation to the top of a mountain. So if he's driving here, then he measures the angle of elevation. This will be the top of the mountain. It's 28 degrees. 1 kilometer closer, and he measures again, and now it is 33 degrees. How high is this mountain here? We'll call that X. So we have 2 right triangles, so that means we can set up our sine, cosine, tangent 2 ways. With 2 equations. So the first one is tangent of 28 equals, let's label this 1, and we'll call this part y. So opposite over adjacent. Cross multiply, I'm going to distribute the tangent, so tangent of 28 plus y times tangent of 28. The second one is tangent of 33 equals opposite over adjacent, and then we will cross multiply again and get y times tangent of 33. So now we have 2 equations. They both equal x, so they equal each other. So y times tangent of 33 equals tangent of 28 plus y times tangent of 28. After you do some algebra, move things around, factor out the y, divide, you end up with tangent of 28 over tangent of 33 minus tangent of 28, which comes out to be 4.5. That is y. We want to know what x is, so I would take this and let's plug it in here, and then you'll get x to be, the mountain is 2.9 kilometers. The next question is from trig packet number 5. So this is also the trig packet. Trig packet number 5. So the rectangle has dimensions 6 and 8. It's inscribed in a circle. In order for a rectangle to be inscribed in a circle, it does have to be centered. So this diagonal is the diameter. And this is a right angle here because it's a rectangle. This diameter is 10. This is a triple, 6, 8, 10. If you didn't know that, you could use Pythagorean theorem. So we do, that means the diameter is 10. The radius is 5. Area of the circle is pi r squared, so 25 pi. The next question is from the 10.3 worksheet, number 2. This is a 10.3 worksheet, number 2. So in this question, we have a radius to a tangent. That means this is a right angle. Also, we have a radius that goes through a chord, and this is also a right angle here. We can see that this is going to be, there are a lot of congruent triangles in here, so that's how we'll know that this is a right angle here. So now We have 8 and 6. We have a couple ways we can solve this problem. BD is 10 because this is a right triangle, and this is 8 and 6, that same triple that we mentioned earlier. We could do altitude. You remember the altitude on the hypotenuse, the geometric mean with like the leg. So the leg squared is the whole hypotenuse times the hypotenuse piece that's adjacent to it. So that would mean we could use 8 squared is the whole hypotenuse times the piece right next to it. So BE, we'll say BE. So BE is 6.4. The other way that you can do this problem is by using area of a triangle. So area of a triangle is 1/2 base times height. The area of this triangle is, 6 times 8 is 24. That's using 6 and 8 as our base and height. We could also use 10 as our base and AE as our height. It's the same triangle, so that means it's going to have the same area. So we could do 1/2 base times height, which is AE, equals 24, because it's the same triangle. So that will give us AE to be 4.8. Now we can do a squared plus b squared equals c squared. Pythagorean theorem. BE squared equals 8 squared. So BE equals 6.4. The next question came from 10.5, number 2. This is the 10.5 worksheet. So AB is 100 degrees, BC is 50 degrees, AD is congruent to BD, congruent there, and we want to know what is this angle right here. We'll call this X. Okay, so because BD and AD are congruent, these are congruent chords in the same circle, so that means their arcs are congruent. So that means this arc and this arc are congruent. So we'll say congruent and congruent. Let's call those X. X and X. So we have X plus 100 equals 360, because that covers the whole circle. So 2x plus 100 equals 360, x equals 130. If x is 130, that means DC, the measure of DC is 80. So this is 80. The angle that we're looking for is an inside angle. Inside angle is 1/2 arc plus arc, the average. So we have these two arcs. We could plug it in, 80 plus 100, and get 90. The next question is number 5, in the same worksheet, the 10.5 worksheet. So we have circle P and circle Q. Tangent NS is tangent at A. MR is 42. So if this is an intercepted arc, the angle that goes with that is this angle here. This is an on angle, so this is 21. This on angle is also it also has an intercepted arc here, which is also 42. So if this is 42 and this is a diameter, then this whole arc here is the rest of the semicircle, so 138. That will make this angle here 69 because this vertex is on the circle and it's half the arc. So if you're looking at it like this, it's an on angle like this. We know this is 138, so the angle has to be half of that, 69, which makes this angle 111. They're supplementary, makes this angle 48. I'm sorry, that's really small. So that's 48. .48 is a central angle, so that makes this arc 48. And now NM is the rest of that semicircle, so we could do 180 minus 42 minus 48 and get 90. The last question is number 8 in the same worksheet. So this is the 10.5 worksheet. So arc DFB from here to here is 223. Arc BD is the rest of the circle here, and that's 137. There was a theorem that we learned last section that was that said that this arc and this angle here are supplementary. These two are supplementary. So that makes this 43. The 43, that angle is an on angle to the bigger circle. So an on angle is half the arc, half of this arc here. So that makes that arc 86. And those are all the questions from office hours. Okay, I'll see you later. Bye.